Still loading. There we go. Okay, we should be on.
Yep. Okay.
And now
Really
I don't know why. Don't know why it's not letting me share my screen. Okay, it is not letting me share the screen.
I could share mine.
Okay, go ahead.
Let me try that. Okay. Does that look right?
Yeah.
Okay. So for number 1, we had for A, the father's genotype was IA, so capital I with the superscript A, lowercase I, and heterozygous for the R and M. For the mother's genotype, it was homozygous recessive for I, homozygous recessive for R, and MN. And the child's genotype was homozygous recessive I, homozygous recessive R, and M. For B, I just used the forked line method and found that, so 1/4 of the offspring would have the B blood type, 1/4 of the offspring would have Rh negative, and 1/2 of the offspring would have the MN. So I just multiplied all those together and got 1 out of 32 of the offspring would have blood type B, Rh negative, and MN. For C, we just use the same method. 1/4 of the offspring would have the A blood type, 3/4 of the offspring had Rh positive, 1/4 of the offspring had M. And so multiplied those together and got 3 out of 64 of the offspring would have blood type A with Rh positive with M. For D, we found that the man isn't correct. It is possible for that child to be his if the father and the mother were both carriers of the lowercase I, so then their child could be homozygous recessive for I and have the O blood type. And if both parents were heterozygous for R, and if the father had N and the mother had MN. For number 2, we found that the parents were, one of the parents was heterozygous for the R and heterozygous for P, and the other parent was homozygous recessive for both genes. For B, we found that both of the parents were heterozygous for R and homozygous recessive for P. For C, one of the parents was heterozygous for R, the other parent was homozygous recessive for R, and both parents were homozygous recessive for P. For D, both of the parents were homozygous dominant for R. One of the parents was heterozygous for P, and the other parent was homozygous recessive for P. For number 3, the inheritance of the coat color phenotype in horses, found it had polygenic inheritance. So just like for number 2, how it had 2 genes controlling one trait, and that made it possible for several different phenotypes. That's what we saw for these horses. And we weren't able to figure out the possible genotypes for all of them. So, yeah.
All right, so for number 4, it's just A through F is just a bunch of vocabulary. I guess I can go ahead and name that off. A is glycosyltransferase and galactose. B, overdominance. C, incomplete penetrance. D, epistasis. E, phenylketonuria. And F, lethal. We weren't quite sure on that one, but we think it's lethal inheritance. G, we'll spend a little bit more time on G and age. Because this is maternal phenotypic dominance, in which the male genotype really doesn't matter, or its phenotype doesn't matter. we have 60% will be dextral and 40% will be sinistral. And that is a 3-to-2 ratio. H, if we were understanding it correctly, H is the same situation in which the maternal phenotype is all that matters. You'll have 40% green leaves and 60% with white leaves. And that is a 2-to-3 ratio. For number 5, color is influenced by one gene with 4 different alleles: black, sepia, cream, and white. These alleles show complete dominance in the order of black being most dominant, followed by sepia, cream, and white. Determine the genotypes and phenotypes of the parents that produce the following offspring in a cross. A, we have a 1-to-1 ratio of black and sepia, in which case we can assume that the genotypes will be capital B, capital S by capital S, capital S. And the phenotype of that will be a black guinea pig crossed with a sepia guinea pig. B, 75% or a 3-to-1 ratio of sepia and cream offspring. In this case, the genotype could be will be capital C, capital S, capital C with capital S, capital C. The phenotype will be sepia with the sepia. C, we have 50% black, 25% sepia, and 25% white offspring. In order for this to happen, we would need a genotype that is capital B, capital W with capital S, capital W. And the phenotypes of those parents will be black and sepia. D, we have a 3-to-1 ratio of the black and white offspring. The genotype would be BW with BW, and the phenotype black and black. So we have 2 black parents that have a 3-to-1 ratio of the black and white. And that is it for our video.